Number 76, solve the following logarithmic equation. 2 minus log x to the power 7 to base 4 over 7 minus log x squared to base 4 plus log x to base 4 all squared is equals to 0. So if you look at this, you can see log x to base 4 is common, isn't it? So when it is common, this power 7 can be written as the coefficient, isn't it? Then this power 2 becomes the coefficient. So this becomes the coefficient of the log, this power becomes the coefficient of the log. So you get 2 minus 7 log x to base 4, isn't it? Over 7 minus this power becomes the coefficient 2 log x to base 4, isn't it? Then it is plus log x to base 4 squared is equals to 0. So you can see here we have log x to base 4, log x to base 4, log x to base 4, meaning we can let log x to base 4 to be y, isn't it? So you let log x to base 4 to be equals to y. So where you have y. So here we have 2 minus 7 log x to base 4 is y, isn't it? 2 minus 7y over 7 minus 2 log x to base 4 is y. So it is 2y, isn't it? You see plus, this is now y squared is equals to 0, isn't it? Y squared is equal to 0. So the next thing, you get rid of the denominator, isn't it? You can start by taking the y squared the other side to make it more simple, isn't it? So we are going to get 2 minus 7y over 7 minus 2y to be equals to y squared, isn't it? Then we multiply both sides of the equation with this denominator, isn't it? We multiply both sides of the equation by 7 minus 2y, 7 minus 2, 2y. Are we together there? Yes. So this cancels out with that. You remain with 2 minus 7y. 2 minus 7y is equals to negative y squared times 7. 7y squared, isn't it? Negative y squared times positive 2y. 2y cubed, isn't it? Are we together? So we can now rearrange that to be a standard quadratic equation, isn't it? We can take everything on one side of the equation, isn't it? So this side of the equation, we can take all this to be on the other side. So positive, we have positive 2y cubed minus 7y squared, isn't it? Then negative 7y going the other side, it becomes plus 7y, isn't it? Then positive 2 going the other side, it becomes minus 2 is equals to 0. Are we together? So solve for y. So you can use any method to solve for y. When you have y is cubed, you can use the Newton-Raphson method, numerical methods. You can use factor theorem if it can factorize by checking the values of y. For instance, when y is 1, do you get the solution? Can you check when y is 1? Is that a factor? When y is equals to 1, we are using factor theorem. So you get the answer to be 0. Are we together? In factor theorem, you just test those integers. You test 1, 2, 3, 4, 5. Then you test the negative 1, negative 2. Because for you to get 2y cubed minus 7y squared plus 7y, meaning they are very small integers, isn't it? Like 1, 2, 3, 4. So factor theorem means, are we able to factorize it into integers, isn't it? So you just go to the calculator and you say 1 is equals to 1. Then now, your y cubed now become answer. So in the calculator you put 2 answer cubed minus 7 answer squared plus 7 answer minus 2 is equals to 0. Can you put that to the calculator? You first starting, now we want to test the values, okay? So have you pressed this in the calculator? Where there is y is answer. You've already started by saying 1 or 0, 0 is equals to 0, isn't it? Then press this. 2 answer cube, y is answer. Minus 7 answer squared plus 7 answer minus 2 is equals to 0. Are we together? So when you press equal signs, what do you get? What do you get? 6 that, isn't it? Then when you say 1 is equals to 1, then you replay, you press that up and replay. What do you get to the answer? 0. So if you get the answer to be 0, meaning the answer to be 0 is 0, that is the root, isn't it? So y is equals to 1 is one of the roots. Are we together? So one of the roots is what? 1. So we found one of the roots y to be 1. But what was y? Y was log x to base. See, y was log x to base 4. So where there is y, can you put the value of y? Y. This implies y, which was log x to base 4, is equals to 1. So it means our base is 4, the index is 1, corresponding number is x, isn't it? So it means x is equals to 4 raised to power 1. The index is the log of the corresponding number to base 4. So it means x is equals to 4. Are you seeing that? By definition of logarithms, isn't it? By definition of logarithms, you can see here 4 is the base, then the index is 1, then the corresponding number is x. So 1 index is the logarithm of corresponding number to base 4, meaning it's the logarithm of x to base 4. Are you seeing that? By definition of logarithm. Or somebody can just come and introduce log 4 to base 4 on the other side, isn't it? So that this one becomes the power. Then you ignore this one is equals to that, you ignore log to base 4 on both sides of the equation, isn't it? Then you end up with x is equals to 4 raised to power 4 raised to power 1, which is just 4, isn't it? One solution is enough. Once you found one root of a cubic equation like that, that one root is enough, but we know there are many roots, isn't it? Some roots may be negative. If you know negative does not work with logarithms when they are not absolute values, isn't it? Are we together? You just use the factor theorem. They will give you a problem where a factor theorem is working, because they know you are doing numerical methods in this module, isn't it? Good.